Good morning, good afternoon, good evening, depending on where you are. Welcome to our session, AI at the Edge, discussing the fundamentals of how to build 5G edge applications, opportunities, and challenges. I'm Janki Vora. I'm a data scientist and also lead the 5G edge solutions and strategy at IBM. I will now hand it off to my colleague, Yvonne, and he will introduce himself and kick off the discussion. Yvonne, off to you.
Thank you, Janki. Good morning, everyone. This is Yvonne Portilla. I'm a data scientist and solution architect with the IBM Edge Computing team. Thank you very much for attending this presentation. Next. The agenda that we have today is very simple. We're going to be talking about edge computing. Then we will identify some of the opportunities and challenges that we have with edge computing. Particularly, we'll dive into 5G and edge computing. And at the end, we'll do a quick demonstration of some of the IBM capabilities in this space. Next, please. So let's talk about edge computing. We define edge computing as placing the workloads as close to the edge where the data is being created and where decisions are needed. Think about that for a minute. Where is data created? When we think about data on the cloud. Think about your songs, your pictures, your conversations that all live in the cloud. But who creates this data? We human beings create this data. We are using these devices, we're interacting with the environment, and we need these devices to respond to the needs of this data being created. So let's do next. Here are some of the opportunities and challenges with edge computing. We identified three major opportunities. We talk about continuous operation, faster insights and actions, and better data control and cost. When we talk about continuous operation, we are talking about decentralize the IT. So we can manage network disruptions and be able to provide more value. When we talk about faster insights and actions, we are talking about taking action close to where the data is being created. Do we really have that time to wait for a message to be sent to the cloud and back? And when we talk about better data control and cost, think about moving all that data and the exposure that creates for people hacking into your data or storing that data in different cloud locations. So let's talk about each one of these individually. Next, please. Continuous operation. Here, a good example is, say that you have a major catastrophe like a hurricane or earthquake, and you want to purchase gas at the gas station. If you have the money, if you have the credit card, why do you have to connect your pump to the cloud if you need that gas right away? So that will be an example of how a continuous operation can help you by, in the point of purchase, when you get that gasoline with your credit card, you get your services, you're out of the way. Let's take another example. Faster insights and actions. Most of you will be using these autonomous cars in the future. And when you're driving an autonomous car, self-driving car, and you're not paying attention to what's happening on the road, you need quick reaction time. Sometimes in the order of 10 to 20 milliseconds to react to somebody crossing in your way. So you need this faster insights and action. You don't have the time to wait for the car to talk to the cloud and come back with a decision to stop or proceed forward. Let's see the next example. Better data control and cost. So some regulations like GDPR in Europe and CCPA in California talk about what data can be moved across borders, what regulations they need to follow. And if you think about the amount of data, for instance, an oil well generates 4 terabytes of data every day. Think about storing that data, protecting that data in transit and at rest. So these are the benefits that edge computing will provide. So now let's dive in more specifically. So Janki, will you take us to the next slide, please?
All right. Thanks, Yvonne. I think Yvonne just walked us through what edge computing is, what are the opportunities and challenges. But the question is, so then what are these edges and where are they? In this slide, as we show, we are trying to classify the various edges. And the first category is the device edge. I think all of us are familiar with them. Our headphones, our Fitbit devices, telemetric devices that are, that we see around us, the connected cars, or, those sorts of old devices that can generate data, have some compute that they can do some sort of analysis on the device itself, and then are connected and can send the data out. So that is the first class of the device edge that we see. The next class is the on-premise edge. With these, as you see up here, the examples are the factory floors, the offices, the campuses, the buildings, homes, stores. What has happened is, because of the explosion of the digitization and sensorization, it has become very eminent that we are able to analyze all of the data that's generated very close and, most likely at these, and manage them on these on-premise locations. Now, moving on to a further right, we see a whole new class of edge that is emerging. That is the telecom edge. I think you've all seen these tall cell towers as we pass by on the highways and roads. We are seeing an emergence of tapping into the compute available on those RAN, or the radio access network sites, which are called also the far edges. Of course, the first wave of applications are most likely going to be network applications. Also, moving on further, as we talk about the telecom edge, what we have seen is an emergence of the telecoms, modernizing their access centers, their metro access centers, as well as their regional and core centers, and making them as mini data centers, allowing the telecoms to reform and transform themselves of just being a connectivity provider to become also an application provider. So these real estates will allow you to sort of set up the compute and allow low latency applications to be run there. Of course, some of the things that you hear around what AWS is doing with Verizon is their wavelength zone is a classic example of those telecom edges. And of course, I think most of us have already heard about various other, centralized cloud edges, like from the IBM cloud, the Azure, the Anthos, and others. So these are the various edges that we see today. Now, as we talk about these edges and the benefits, what is really going to happen with these edges? What are they going to help us with? I believe they will reshape our industry. And we are already seeing what is happening. I think as you see from finance to the way we drive to kiosk, healthcare, manufacturing, our retail, variety of all of our industries are going to be transformed with the advancement of edge. I'll touch on a few examples here and then go on to some of the details as we discuss further. So one of the examples, as we see, is around how edge is going to transform the finance industry. We see several ATM machines now being able to really do analytics at the edge, and not only that, being able to bring down operational costs if there is an update on those ATM devices. As a bank, you can easily operate those, as well as bring new kinds of better, improved client experiences by modernizing the ATM machines and allowing to compute and to run the applications on the ATM machines itself. Taking on healthcare, it will, as we see that there are several of these telemetric devices and heart monitoring and sensors that are enabling and modernizing our healthcare system, there's always the scare of privacy and security. But what if we're able to now analyze that data at the edge without having to worry about security of transferring that data outside the premise? That is transformative. The biggest transformation I see is going to happen is in the manufacturing domain. We'll see novel kinds of applications which will help reduce downtime, improve throughput, and also improve the worker safety. I think manufacturing is further going to be fueled, and also the edge applications that we just discussed are further going to be fueled by 5G. And what does 5G mean? So what is 5G going to bring us? We are hearing all about it. I think I've tried to describe them in three main currencies up here. The first is the enhanced mobile broadband, which is going to allow us to improve user experience, bring better device connectivity, allow high bandwidth, high throughput. Basically, the movie that I can download, that I'm today downloading on 4G that takes about 20 minutes, is going to now take 2 seconds. So you can see how that is going to transform our lives. And I will later discuss how it's going to transform our industries. Moving on to the second currency, which is the massive machine type communication. As we discussed, one of the edges are the sensor devices. There are going to be millions of these devices. So with 5G, it's going to allow about 1 million devices to get connected in a square kilometer area, which is not possible with a regular 4G or Wi-Fi and such. Moving on to the third currency, which is the ultra reliable low latency communications that 5G will enable, which will now really make the connected cars and self-driving cars a possibility in a safe way. The drones that will be autonomous and autopiloted, the robotics that will now be possible, and the remote healthcare that will be made possible is all critically going to require very low latency decisions and connectivity that needs to be made, and that will be fueled by 5G. 5G, as I described, along with the edge, is completely going to transform our era. In fact, these are, as you see, a variety of innovative use cases that are going to be possible. What I'm showing on the slide is what the government of Italy did was sponsor the operators of 3 countries, Milan, Rome, and Germany, and allowed them to come up, roll out those 5G networks and challenge them to bring in new innovative use cases that are ranging from transforming healthcare, remote surgery, as you see here, bringing safety to their cities, the 4.0 citizen, improving healthcare through wearables, bringing precision agriculture to the farmers, education 4.0, virtual classes, AR, VR kind of applications, manufacturing and industry 4.0 use cases, as well as robotics and drones. So you can see a variety of these use cases that the operators came with. And this project started in 2018. There's a lot of public publications and material available. I was personally involved in working with the University of Surrey as well on some of the projects around 5G and edge. And the highlighted ones are the ones that I've been personally involved in working with some of the telcos and our enterprise clients at IBM. And we'll share a little bit of insights and story what we are seeing, how 5G and edge together are going to transform all our lives. So the first one is the industry 4.0, as I mentioned. The edge is going to allow devices to process quality feed in real time and determine whether it's the quality of a product is good or not. And 5G is further really going to enable, as I mentioned, millions of devices to be connected, being able to take hundreds and more cameras to really stream in real time and make such analysis possible. So together, they transform and bring a revolution in our industry. The second is predicting maintenance or asset health, being able to analyze data and predict maintenance is possible due to the edge. And 5G further enhances, I would say, wireless connectivity. Today, all our factories and robots are all wired. With 5G, you can get disconnected and still get really good bandwidth and throughput and allow low latency for remote machine control and maintenance, and allow applications like AR, VR to further make the technicians more efficient. The third is enhanced worker safety. And during this pandemic, we have a completely different lens of safety, allowing our factories to still work but while their manufacturing employees are remote is going to be possible with the power of edge and 5G brought together. Detecting a fall or a sort of a hazard in real time and notifying the security is imminent, and edge and 5G will make that happen. The second set of 5G use cases that I have been personally involved is bringing and transforming and bringing is around the 5G stadium experiences. Today, because of the pandemic, we know this is what our stadiums look like, and bringing our fans safely back into these games, employing 5G and edge and AI capabilities together to, in real time, manage and monitor face mask detection, social distancing, managing crowd density, safety of our fans, and not only that, as we progress, being able to do queue monitoring and providing better fan experience, and bringing AR, VR, and other capabilities is going to be possible by bringing 5G and edge again together. Finally, this is my final scenario before I hand it off to Yvonne for a use case demonstration. Milan also, and IBM worked with Milan on and Vodafone for their safe railway or use case. And the idea, again, was, as you see in this diagram, several 5G cameras were set up, high bandwidth and low latency analytics. So because you want to analyze any threat situations, abandoned objects, person who's laying on the ground, or abnormal flow of the people, all to be analyzed in real time. What we did was created models on our IBM cloud, which was in the 4 categories that I described is our traditional centralized cloud. The model was developed on massive amount of data. And once the model was developed, it was containerized and pushed out to the edge, which is, again, can be, variety of those edge classifications. We tried to use the telecoms edge, as well as on-premise edge, which was at the security station, and do analytics in real time to identify any security threats. So with that, I'm going to hand it off to Yvonne and go through a live demonstration.
Thank you, Janki. So I want you to meet Elsa. She's a global security company CEO. This is a recent demonstration we did with a client in Europe. And she shared this quote with us. She mentioned that managing these hundreds of remote devices is very complex. She doesn't have all the resources to update what software is running on these devices, these surveillance cameras, and she's struggling. So she approached us with the following goals on the next slide. And I'm going to tie all of these goals to the 3 opportunities we mentioned before. So her first goal was to be able to run these AI-based surveillance applications, even when the cameras are disconnected from the cloud, to prevent service disruption and revenue loss. She also mentioned that she wants to improve speed to actions. she wants to take action once an intruder is detected right away. She cannot wait 2 or 3 minutes to call the police to take action. So by running the inference closer to where the data is captured, she wants to improve the speed to action and grow the opportunities. And finally, she wants to minimize the cost of transporting and storing that data and reducing the exposure to hacking while maintaining compliance with legislations like GDPR. So again, continuous integration, faster insights, and better data control and costs. So we did a demo for her company, and I'm going to show you here the demonstration. I'm going to switch from the slides. If you go to the next page, Janki, I'm going to show you our product and show you how we can manage these devices from a central location. So I'm going to start sharing my screen. And so Janki, you will stop your screen and I'm going to start sharing. And let me know if you see my browser. So right now, you should be able to see my browser application. So do you see that? And this is the product called IBM Edge Application Manager. So my screen is a little small. I just make it as bigger. And this product called IBM Edge Application Manager enables me to have a secure, robust lifecycle management of all these services and all these devices. And what we're looking at here is called the dashboard. The dashboard is hosted on the IBM Management Hub, which can be placed where it's appropriate. It can be on a cloud, on a regional data center, or even at the factory floor, totally air-gapped from the internet. On this dashboard, you can interact with thousands of edge devices from a central location. And it doesn't matter the hardware or software characteristics, you can manage what applications are running on these nodes. So here we're looking at the nodes view, and we can switch to a graphical view. And we can see that we have a total of almost 800 devices that we're managing. And we can tell additional information about what type of architecture those devices are, what was the last time they connected. So I can switch to the tabular view and I can see the details. Who's the owner of that device? What was it last time it was updated? Does it have a heartbeat or not? So for this particular demonstration, I'm going to find my camera. So my camera is called Ahmed, and I found my camera here. And now I'm in the configuration details of my camera. I can tell who the owner is. I can see these collections of properties and constraints, and that make the camera policy, and that tell me what type of workloads or services I can run in this camera. So I can see here that my camera is of a type smart camera and it has a GPU enabled. And because of that, then I can run some inferences on that camera. I can also see constraints, and most importantly, I can see what service, what workload service is running on the camera. Think of a service like an app in your phone. What apps are you loaded into your phone? Similar to what services can you run on these edge devices? So if we go out of that and go into my camera, I can see that it's pointing into my backyard and it's doing a detection, face detection of who's approaching my house. So I can analyze and I can draw a box around the person's face and I can tell, oh, that person hasn't been here in my house before, it's the first visit. So again, from a central location, I'm managing these devices, continuous integration, faster insights, and better data control costs. So now what I'm gonna do is I'm going back into my node and I'm gonna change the characteristics from a central location, and I'm going to enable additional capabilities on that camera. I've been told that we had a TPU, tensor processing unit in that camera enabled. Now I change my characteristics and I'm going to redeploy a new service. So when I do that, I go now into my camera and I can see that I can point it to a different angle and I can see social distancing, very important in these pandemic days. So now I can analyze social distancing and you will see green and red boxes. So green boxes meaning that you are 2 meters apart, 6 feet apart, you're okay. Red boxes are you're closer than 2 meters or 6 feet, and there's an alert. So again, from a central location, I was able to reconfigure my camera without sending somebody to the field. Very secure, highly scalable, thousands of nodes in a very faster way. So with that, Janki, I'm going to stop sharing.
Thank you, Ivan. Appreciate the deep dive and demonstration showcasing Edge and AI brought together, and 5G would only accelerate it. Hope we were able to share and walk you all through the value and the transformation AI and Edge will bring together. And 5G will only fuel it and transform our lives. Very excited about that. And here are some resources. Feel free to reach out to Janki, Vora, or Ivan Portilla on our LinkedIn as well. Look forward to that. And thank you.